In this video, we're going to build the climb ledge state. This will be an action the player can initiate while in the hang state that allows them to climb up to the surface they are hanging from. Let's start by creating a new script in the player states folder called climb ledge state. We'll create this state in the usual way by inheriting from player state and implementing the base class constructor call. We'll also include init and begin playing the climb ledge animation in this method. Then we'll instantiate a new climb ledge state for our player's state dictionary. Remember, we already added the value to our enum in the last video. Now we're going to extend our hang state a little bit to prepare for the transition to the climb ledge state. One problem we want to avoid is that we will use an up input both for hanging and for climbing the ledge. So we want to give the player a moment to decide whether they want to climb up. If we didn't add a delay, then they would start hanging one frame and then immediately begin climbing up the ledge the next frame. They would need to release the input in a single frame to avoid this. It would be much better if we simply started a short timer that prevented them from climbing until it was finished. We'll introduce a new private variable into the hang state called nextClimbLedgeTime. And when we initialize the hang state, we will set this to the current time plus some constant amount of wait time that we will define as a new settings variable. We will add a new variable called hangBeforeClimbTime, and we will set this timer to 0.2 seconds. Now we can return to the hang state and add this to the current time to get our next climb ledge time. Now we will introduce the managedUpdate method so we can check each frame whether the timer is finished. We will first check to see if the player is entering an up input. Then we will see if the current time has reached the next climb ledge time we set. If both of these conditions are true, then we can transition the player into the climb ledge state. Now we're going to move to the player script and introduce a coroutine. A coroutine is basically a method that we can set to run in small parts over the course of many frames. We set up the method and tell it where to pause each frame, and then Unity keeps track of running that part of the method every frame update. This should make more sense once you see it in action. For reasons that I will explain soon, we are going to start the method by immediately pausing for one frame. To do this, we use the keyword yield and then provide a return statement. To pause for a single frame, we can simply return a null value. Then we are going to set up a while loop that will allow us to do a small amount of work each frame. The condition we are going to use will check to see if the current animation has finished playing. Using the animator component, we can retrieve the normalized animation time, which is a value between 0 and 1 that represents how far along the animation has played. So this while loop will continue running until the current animation has finished playing. And since we are going to start this coroutine when we initialize the climb ledge state, this will be the climb ledge animation that is playing. One problem is that we are going to start this coroutine from a player state, which is not a Unity component. This means it does not have access to the start coroutine method that we need to begin this whole process. We will solve this by simply exposing a public method in our player class that will call the start coroutine method itself. We will call this method runClimbLedgeCoroutine, and the only thing it will do is call the climbLedgeCoroutine method and pass the enumerator that is returned to the start coroutine method. This is the way that we begin a coroutine. The enumerator that is returned by the coroutine method is what Unity uses to keep track of the method execution in between frames. Now we can go back to the climb ledge state and use the player variable to call this runClimbLedgeCoroutine method right after we start the climb ledge animation. This is why we needed to pause for one frame before entering the while loop, because the animator will not begin playing the new animation until this current frame is finished. This means our while loop could immediately exit because the previous hang animation is going to be on its last frame, since it only has one frame. But if we wait for one frame, then the animator will switch over to the climb ledge animation and our while loop will run correctly. Now this is a bit anticlimactic because the only thing we're going to actually put in our while loop body for right now is a comment and another yield statement. This is because the purpose of this coroutine is to control the movement of the camera while the player climbs the ledge, and we aren't going to introduce the camera system until the next video. Most of the actual work of the climb ledge action is really done by the careful setup of the climb ledge animation we talked about in one of the first videos. We're using a climbing method that is from Mario 64. To help illustrate this, I've slowed down the animation so we can look at what's happening closely. The player's position actually remains at the bottom of the ledge the entire time the animation is playing, but the animation simply makes it look like they are climbing up the ledge. Then as soon as the animation completes with the player appearing to be at the top of the ledge, we instantly move the player's position up to the exact position they appear at. Remember, the climb ledge animation frames are 4 times larger than the frames for our other animations. This is so that there is room to climb up within the frame while the pivot position stays at the bottom corner. The pivot, or the position of the sprite, is marked by the blue circle at the lower left, so that never changes while it appears like the player is climbing up the ledge. This is the reason we need the coroutine, because we are going to introduce a camera that follows the player's position in the next video, and this would lead to the camera suddenly jerking up to the top of the ledge rather than smoothly following the climbing animation. But for now, we'll end the coroutine by calculating where to place the player after they finish climbing. We will introduce a new setting called Climb Ledge Offset to store this offset. I basically just had to play around with the sprite animation to figure out what these values should be. Now we can use this offset to correctly set the player's position after they finish climbing. The player can climb up from the left or the right, so we also need to take their scale into account again. We will also set the velocity to 0 just in case they still somehow had some damping velocity, and then we will place them back into the move state so they are free to move around again on top of the ledge. For some reason, the climb ledge offset in game settings was set to 0, so we need to change that before we test this out. We'll just delete the asset and then create a new one because this will pull in all of the default values we set in the script. Now let's run the application and test out our climb ledge action. We should be able to grab onto a ledge, wait for a moment, then enter an up input to climb onto the ledge above. In the next video, we'll introduce a camera system that follows the player around on the stage so we're not stuck on one screen. And then we'll update our climb ledge coroutine so that the camera smoothly follows the player while they climb up the ledge.